there. There's the front. Here's the line. Two are meeting. Clouds building over top of the cold mass. The warm air is building over top of the cold, like a snow on a shovel kind of. Cold is shoveling up the hot air mass over top of it, and as that hot air mass is being pushed up, it's cooling, and the moisture in the hot air mass is going from warm vapor to condensation due to its lack of molecular activity or reduction of molecular energy in the form of cooling. And the cloud forms and grows and billows up out of the lower levels of air that are against the ground. That cold air is pushing the hot air up. Hot moist air. The hot moist air is being pushed up. It is condensing, and then where the two meet, the hot air releases its moisture, drops down to the ground, and then you've got you got tremendous amounts of water interaction hitting each other, dropping out of the cloud, causing a potential difference where there's less electrons in the cloud than there were before, and then you've got voltage, and the voltage builds and builds and builds until you've got a magnetic, static electric attraction to the point where it creates a conduit in the air, which is technically not a conductor, but can be, especially when it's moist and has nuclei, especially salts. And then you have a voltage discharge in the form of lightning, going from either the ground to the sky or the sky to the ground. And so we've got a really nice specimen here right now. Very dark, lots of condensation happening. Mike! Look at that. That's dark right there. Moist air. We were in nice sunny skies a moment ago, very clear, and rapidly going into dark skies here. Obviously the moisture absorbing all the UV, blocking the UV. Large amounts of energy are being deposited into the cloud, into that air mass by condensation, because the water vapor is energetic. That's why it's a vapor, because it has enough energy to be in that phase, in the gas phase. And when it gets pushed up to the when it gets pushed up, atmospheric pressure decreases, temperature decreases also, and the end result is you have a molecular slowdown or cooling, aka cooling, of the cloud air mass and the moisture that's in it. And what that results in is a condensation. If there's any particulate in that cloud, which I'm sure there is, more than just oxygen, nitrogen, and water, there's some particulates. That water that's getting now slow in its molecular energy will condense on that surface, that nucleation surface, dust, whatever it is. And when that happens, all the heat energy, that latent heat that was in that water to make it a gas, now gets deposited onto that hard surface, and now that hard surface has just absorbed a bunch of additional heat and additional energy, and now you warm the air mass again after making it wet, after letting the water condense out. Then that gas, the vape, the oxygen, the particulates, all those things now absorb the heat energy from that water, and then the cloud as an air mass rises more, and that's where you get the cumulonimbus, or whatever the big storm cloud is. It gets bigger and bigger and bigger, and you have like a domino effect, a compounding effect, to create this huge storm cell. And then you've got lots and lots of electrons that are being exchanged rapidly. And again, this voltage is created. All that water is dropped out. And you get voltage from just the sheer amount of water that's changed places, and also from the collisions that happen to the molecules in the water, because inevitably some stay in the cloud, and you've got tremendous voltage difference in the process. And that's where we get to see our light show.